Imagine waking up tomorrow to discover something impossible. Earth has suddenly stopped spinning. For just 5 seconds.
Earth is already spinning incredibly fast. At the equator, the surface moves at roughly 1,670 kilometers per hour, and we move with it. But here's where the most important physics begins. If the ground suddenly stopped, everything on it would not instantly stop with it. Objects would tend to keep moving because of inertia.
And the atmosphere would be affected too. The air is already moving with Earth, so a sudden stop in the ground would create enormous relative motion between the surface and the atmosphere.
The effect would not be identical everywhere. Earth's rotational speed is greatest at the equator and becomes smaller as you move toward the poles. The oceans would not simply freeze in place either. Water already has rotational motion, so a sudden change could create extreme movement relative to the surface.
Buildings and infrastructure would face another problem. They are connected to the ground. Infrastructure would face extreme stress.
One common misconception is that everyone would simply fly into space. That's not how gravity works. The bigger danger would be violent relative motion, not gravity suddenly disappearing.
But remember, our scenario lasts only 5 seconds. That makes the next question even more interesting. What happens when the rotation suddenly returns?
Then, after 5 seconds, the rotation suddenly returns. Now the same physics happens in reverse. Everything has to respond to another abrupt change in motion. The atmosphere would also respond to this sudden change. The air has momentum of its own, so stopping and restarting the surface would create major change. The oceans would face the same fundamental problem. Water has momentum too, so a sudden change in Earth's rotation would create powerful relative motion between the oceans and the surface. The most important effect would come from this difference in motion. The ground changes suddenly, while everything around it cannot respond instantaneously. The effect would also depend on where you are. Earth's surface moves fastest at the equator, while rotational speed becomes much smaller toward the poles.
Before the stop, the atmosphere and surface are moving together. But if the ground suddenly stopped, their motions would no longer match. Structures are connected to the ground, so a sudden change in motion would transmit forces through buildings, bridges, and infrastructure.
We normally never notice Earth's rotation because we, the ground, and much of the atmosphere are already moving together. A sudden stop would break that normal relationship. Gravity would not suddenly disappear. Earth would still pull everything toward its surface. The dangerous change would come from motion and inertia, not from gravity switching off. And there's another crucial detail. Earth stopping its rotation would not mean it stops orbiting the sun. Those are two completely different motions.
5 seconds may sound incredibly short, but in this scenario, the problem is not simply how long the rotation stops, it's how suddenly the motion changes. And then, after 5 seconds, Earth starts rotating again. Now the system faces a second sudden change in motion. The return would create another abrupt change. Anything that had continued moving during the pause would now have to respond to the rotating surface again. The surface, atmosphere, and oceans would not all respond in exactly the same way. Their motion and interaction would determine how the disturbance develops. The surface, atmosphere, and oceans would not all respond in exactly the same way. Their motion and interaction would determine how the disturbance develops. Because rotation helps shape atmospheric circulation, even a temporary interruption could disturb the patterns that normally organize global winds and weather. A dramatic change in Earth's rotation would not go unnoticed. Modern instruments and satellites can measure Earth's motion with extraordinary precision.
Rotation change detected. Scientists already monitor tiny variations in Earth's rotation. A complete 5-second interruption would be vastly beyond ordinary fluctuations. Some popular explanations go too far. Earth would not stop orbiting the sun, gravity would not vanish, and the planet would not simply explode. And this is where the duration matters. A 5-second interruption is very different from Earth permanently losing its rotation. If Earth never started spinning again, the consequences would become a completely different story. But our scenario lasts only 5 seconds, and that distinction is crucial.
Once those 5 seconds end, Earth would be spinning again. But the effects caused during the interruption would not simply disappear at the same instant. The deeper physics comes down to momentum. Earth is not just a solid ball. Its atmosphere, oceans, and interior all interact as a complex rotating system. Earth is also not a perfectly rigid object. Its solid layers, oceans, and atmosphere interact, making the real physics far more complicated than a simple spinning ball. But there is an important reality check. There is no known natural event that could simply switch Earth's rotation off for 5 seconds and then restore it perfectly. Even though this scenario is impossible in practice, it reveals something fascinating: how deeply motion is built into the world around us. So if Earth stopped spinning for only 5 seconds, the most important lesson would not be about an exploding planet.